Lapo, great to have you here. First of all, let's just ask a very basic question. What is Tecla? Is it an acronym as well?
Yeah.
What's it stand for?
First of all, thank you for the invitation.
You're very welcome.
Tecla is inspired by one of the invisible city of Italo Calvino, the city in continuous moving, in continuous construction, and moreover, it is the acronym of technology and clay. This because since from the name, the idea was to put together and create a strong link between past and future, using old material like raw earth with new technologies like 3D printing. So we decided to link it in the name. So this is the real reason of the technology and clay together.
And how did the idea start? Why was this developed at all? What was the catalyst?
Yeah, I mean, Tecla was a project developed from 3D Wasp, an Italian company specialized in 3D printing, and Mario Cucinella architect. The idea since the beginning was to test if it's possible to build houses by using soil, local soil, and so to respond to the demand of affordable houses and greenhouses without the use of large quantity of materials, of raw materials and energies. So, of course, if we take a look into the image that we are around, we can understand that it's not a model of house for high density cities. Is an house is not an I mean, is an habitat imaginated for out from the city where is needed after catastrophe, after war, where is needed to create a shelter in a very short time with quality material but low cost material. So those are the ideas. At the beginning, we start with wasp by imagining this house like the house of a pottery wasp, because if we take a look into a small pottery wasp, it take the soil around and it collect together to create this very small shell, perfect for putting inside the eggs. So this was basically the idea. Do the best with what we have around us.
So we're talking about a natural material, pure clay. Is this pure clay?
I mean, I started work on clay 8 years ago, and I mean, it's not true to say that it's possible to use all the clay that we can find around the world.
There's clay and there's clay.
Yeah, exactly.
Right.
I think that it's more correct to speak about soil, because I mean, clay is one of the parts of the soil. We have sand inside it. We have different parts that compose silt. We have different parts that compose the soil. In specific region around the world, it's possible to use it, considering that 1/3 of the human population live in earth house. So it's really common, no?
Right.
Unfortunately, no one that these people are really happy, because of all these houses are in a place around the world with not a lot of money, so not high quality of construction.
Did you say, what was that statistic? 1/3?
Yeah, of course. Yeah.
Where does that come from, that statistic?
Africa, Asia. So in a lot of places, South America, a lot of in Mexico, there is a lot of different techniques, of course. No one used 3D printing, that's to be safe. But I mean, the use of soil is really huge.
So we're talking about so that we have the material, and we'll come to the process in a second. The research development process. It seems to me one thing that's critical here is that the potentially, ideally, the material comes from the site that the structure is built on.
Yeah.
So there's no transport involved, or very little, I guess.
Yeah.
It's part of,
From the R&D side, the first phase of the project was to understand which kind of soil we have on the site that we decide to use. So this is the largest initial part of the project. Because as I said, it's not possible to use all the soil, so we need to understand which kind of soil we have. and which is the best mixed design to use this soil. So we collaborate with Mapei, a big Italian company, chemical company, to find a way to stabilize it. So we add rice straw. We use rice straw because it's a very big waste in Italy. We have a very large production of rice, so there is a lot of trash due to this kind of industry. And we add 5% of limestone, this to stabilize our soil. Moreover, another 5% of sand to reduce the shrinkage. All those thematic, engineering thematic. But I mean, when we decide the mixed design, as R&D, we start putting together this information with engineer and the architecture studio. Because I mean, it's an holistic approach from the R&D side that put together all these different aspects. You need to consider that the aesthetic of this project emerge from engineering and from material, and it's something quite different from what we can find around us now. Since the beginning, the aesthetic is strongly related with the potential of the material, and this is
so the material and the way in which the material is delivered in this additive way dictates the from an architectural perspective the creation of volume, the creation of form, and so on, and the particular aesthetic. How long was that process, and can you tell me what the various kind of milestones were in that process?
Yeah, I mean, in the process or in the project?
In the R&D process.
Okay, so we start from the material. We go with the engineering studio into analyzing the strength of the shell in the phase of construction, because as you can see in the video, the printer work layer by layer, so we need to verify the structure step by step. And this was quite difficult, but we need to be sure about the resistance of the entire shelter in all times during the building site phases. After that, we try to create a parametric system able to adapt this shell to different locations. And this was a work that R&D made together with SOS School. And we worked with the students, you can see here, where we use the parametric data of the site, so the environmental data, the sun, everything, and we try to put together in a way that we can create the perfect wall for this kind of location. When we have all this material, we start to work with the more architectural side, so closing the work, and we create all the furniture, because everything was designed to be more fluid with the shape of Tecla, and we close the entire project. So just in the last part of the project, we go deeply into architectural solutions. At the beginning, everything was related to material and performances.
So you have this, what we've seen here, the prototypes, the kind of the experimental case study, and where is that, first of all? Where is the site?
It's close to Bologna.
Close to Bologna. Okay, yeah. So on home turf.
Yeah. Yeah, and for a logistic region.
And I mean, the way it's programmed to, as you say, to create this particular form, which is redolent of a kind of wasp's nest. In terms of the actual capability of the printing process, this additive process, what is possible? What kind of forms are possible? Is it at the moment very limited in scope because of the material, because of maybe the current limits of the performance of the actual printer? There's not much else possible in terms of form, or is there?
Yeah, I mean, I remember maybe in 2007, people started speaking about 3D printing, and everyone was saying, with 3D printing, it's possible to print every kind of shape. No? Any kind of shape is possible to be realized with 3D printing. It's not completely true. There are a lot of limitations, and we test this because, as you can see, we print a lot of mock-up before starting closing the project and understanding the limitation of the technology. As I mentioned, everything is strongly related to the material. Nowadays, sometimes we don't think as the material. We don't think with the end, Mario said, no. So we think separately from the material. But in that case, everything was driven from the behavior of the material. So it's possible to print with two printer like what we have done in that case, because we print in a collaborative way with two printers together, and this is the maximum that the printing technology can make at the time, so 3 years ago. I mean, it was an experimental project, so probably in the next year there will be some improvement of the technology, some improvement of on the material side. But this was I mean, we were very close to the limit, very, very close to the limit.
So what we see here is really at the limit. Can you print upside down? Not you personally, but I mean, is it possible to kind of can the printer head be? Or
Yeah.
Are we really? Do we require a certain kind of gravity and a
Vector to print, aligned to the object. And there are several different projects that make something like this, not with soil, a project related to printing with metal, where it's really relevant to print aligned with the surface, and this help a lot. I mean, as I mentioned, this was printed with the Crane Wasp, and this is a 3-axis machine, so it's the best that the machine can make.
How much material do you need to create a structure like this? Because we think about, if we think about concrete, for example, we have an idea of how much is needed. We know what the embodied carbon is involved. I mean, for example, tell us about the sustainability credentials of Tecla versus kilogram for kilogram in terms of material. If you were to compare this with concrete, carbon plus the amount that's actually needed to create a structure of a similar size.
Yeah, I mean, the logic behind Tecla is completely different from all the logic that we can see in all the 3D printing with concrete project that you can find. We are in Germany, and in Germany there are a lot of 3D printed houses with concrete. For me, that I am of the field, I know that there are a lot of projects 3D printed. But I mean, when we start a project, we try to optimize it to something, no? In the case of concrete, of course, if we want to make something affordable and green, we need to reduce the amount of cement that we use. So immediately the idea is to print, a contour crafting, so the inner shell and the outer shell with no infill, because we need to reduce. But we have high performances, so we are working in a completely different way. In that case, the material is very low performances, it's raw earth. So no CO2 embedded, because we dig it out, this from the building site, 10 meter. We just filter it and add a 5% of limestone and a 5% of sand. When we made the LCA calculation of this project, we discovered that the largest part of CO2 is in the sand, because of the transportation. It was crazy, no? But if we made the entire life cycle of this, the sand, the transportation of the sand was the largest emission of CO2. In that case, we decided to use a huge quantity of material, considering that for a project like this, we are speaking about something like 80 tons of mix. Is a lot. Is a very. If you take a look on this image, you can see all the infill is strongly filled with earth, and in the cavity we put the rice husk.
Oh, they're actually in the cavity.
Exactly, to improve the insulation of the system.
Right.
So, if we spoke about, the sustainability of the project is really high for a second reason, that is a quite a monomacharic project, because the largest part, the 90%, is soil, and another 10% of volatile parts, the part of the straw, is a vegetable. So we can destroy it and leave it where we found. So from that point of view, is really sustainable.
Do you think? How adoptable I mean, so you experiment, you innovate, you come up with a completely new construction technology that's discontinuous with what we've had before. But building regs are still, 10 miles behind you. I mean, this isn't regulated, right? This is what I mean. How did we get there? How did we get to a point where this becomes truly feasible and it's fully regulated, and we could see not just kind of prototypes built, but actual habitable houses?
In Italy, we usually say that the problem is the politics. No, we are but in that case, it's not true for me, because I mean, we need case study. We need more case study. Is normal for me, no? When concrete started in the beginning of the 19th century, no one trusted on it. No, it was crazy. It's something. I mean, liquid. What is liquid stone? And after a lot of case study, people said, okay, it works. So now we patent it and we start work a lot, and we create the work that we know very well with a lot of concrete. No. For the 3D printing is the same. So at the moment we haven't the critical number for starting, say, okay, now is the time to make the regulation and start. So every time we say, okay, we need to collaborate with people, and we need to spoke about that, and we need to create, a sort of consortium with more people and work on that to create new case studies. And only by speaking about that and showing that it's possible to arrive at a sort of starting point for the real world.
Yes, there needs to be proof of concept. But it's always a two-edged thing, isn't it? You want to prove the concept and make them, you need to show the feasibility of something like this, where you have people living in these structures in order to kind of win over not only the kind of the regulatory bodies, but also the public generally. I mean, I don't know, I'll put this question to you in a bit, what you think of this. Is it something you would actually like to live or work yourselves? I mean, it has a particular aesthetic. It's interesting you talk about designing furniture specifically, or fixtures, I think you said, or furniture specifically for these structures. There's a certain amount of you have to be on board with the aesthetic, I think, to kind of want to. Do you think, are you exploring other materials for deployment with this particular printing technology?
Yeah, of course. We print with different materials.
What would they be?
Yeah, it works well. Material based on limestone, all the ancient Roman concrete. If we imagine a project like this able to be adapted to different contexts and different communities, of course, it's really nice to imagine this project adaptable to different locations. No, if you take a look into the past, for example, the Roman were go in different places, change a little bit architecture to use what they found on the place that they were. Sorry. This is the same. It's a parametrical project, so we can change some parameter, and we can reduce the infill, and we can use a material with more CO2 embedded and more resistance, but it works well. So we want to imagine this project as a fully adaptable project on the shape and on the material, because we don't think that the use of just one material is the key for the future. We trust a lot in biodiversity, so the best material for the place is our mission.
And thinking about place, and bearing in mind that the overarching concept message for this particular fair is connecting communities, what potential does Tecla have for communities in terms of designing their own structures, building their own communities in terms of materially speaking? Can you see a real viability there, Lapo?
Yeah, I trust a lot on that, because in our profession, if we go a little bit back, to the Renaissance is the starting point where architect and engineer go off from the building site. And from that moment, we became scientists and we work inside studios, and we never have contact with materials and with the building site. But with 3D printing, it's possible to create a strong connection between the studio, so the architect, the people that design, maybe the community, I don't know, the person that design and the building site. So we can be, I mean, the owner, the real owner of the material and the technology. Because, I mean, there is no blueprint. There is a code that from our computer, from our CAD, go inside the machine. So it's a very strong link. And in that field, it's possible to imagine an architecture really related to the site. So where a machine can shape the best material of the site in the best way for the culture of the site. And this can create an incredible biodiversity around the world. And I think, I really trust that this is what we need for the future. No one technology best the other,
Right.
but a real and large environment with different new technology that can help different communities to work with the best that they found locally, as what we can see before the industrialization. Everyone is working with local material. Today we work with bricks that arrive from I don't know how many kilometers from our from the site.
Right.
So I mean, I think that this is the incredible novelty of 3D printing.
I mean, it would be really interesting to see if and when 3D printing reaches the stage where it is, it's so incredibly can adapt to the formal needs of local communities as well. So it could tap into, as you say, more kind of local, vernacular design. So to see those kind of structural parameters fall away. Absolutely fascinating stuff, and really, really timely. And I'm really excited to see what happens next. What do you think will happen next with Tecla?
Yeah, I mean, go back to this point because I think that one more thing really nice could be that experts from all over the world in a future where communities can use new technologies, can share on the web the information related to the use of a specific material. So we can imagine a world where just information going around and transfer the local knowledge, but not the local materials.
Right.
And this can drastically change our approach to the architecture.
Right. Absolutely. Absolutely. Very democratic. Thanks very much, and to that gentleman, for being a great audience. And I hope you agree this has been a fantastic, really, really insightful talk. So thanks very much, Lapo, from Mario Cucinella Architect.